when you have two quadratic roots and if they are interchanged somehow and the result remains the same, they are said to be symmetric. But if they are interchanged or multiplied by -1 and the result is not the same, they are said to be asymmetric. Now we have about 5 features of quadratic roots. We have been asked to determine if they are symmetric or not, especially when alpha is not equal to beta. That's the condition. Alpha must not be equal to beta. So determine whether or not the following quadratic roots are symmetric. We are going to determine that right away. So what do? We are going to assign the simplest values such as 1 or 2 and 3. Okay? We are going to assign maybe 1 and 2 or 2 and 3. So let's see how it goes. We can't just say this is symmetric without confirming it. We can't just say number 2 is symmetric without confirming it. Okay? We can't just say the last one is symmetric without confirming it. That's what it means. We must do something to prove, okay, this is symmetric, that is not symmetric, this is symmetric, and that is not symmetric, and so on and so forth. So let's begin. If we start this by stating, by just assigning, if we say let our alpha be given as 2, okay, and beta be 3, that's at least small numbers for easy manipulation, right? So let's see, we have assigned alpha 2 and then beta 3. So let's see if we can determine whether this is symmetric or not. We start with question number 1, okay? Or feature number 1. Whether it's symmetric or not. Let's see. This is alpha, right? Okay, we take question number 1. And the question number 1I is, that is alpha plus beta is equal to beta plus alpha. Let's see if it's symmetric or not. Since we have alpha is 2, beta is 3, and then beta here is 3, then alpha is 2. Let's see, 2 plus 3 is 5. Okay, 3 plus 2 is also 5. Therefore, number 1 is symmetric. Number 1 is symmetric. Let's see, it's symmetric. Okay, that's what it means. Can you see? We interchange this, the original roots, we interchange it here, and then apply small values, and we have the same thing. It means that this is symmetric. We'll go on to question number 2. Question number 2, let's see if it's symmetric or not. We are going to retain the values of the alpha and the beta respectively until we finish the entire 6 features of quadratic roots. In each case, we are expected to determine whether or not it is symmetric or asymmetric. Now, let's go. Question number 2 is alpha beta is equal to beta alpha. Let's see. We don't just want to assume alpha is 2 times beta is 3 equals to alpha, beta is 3 times alpha is 2. Let's see. Let's see how it goes if we can confirm that it's symmetric or asymmetric. Okay? So 2 times 3, of course, 2 times 3 here is 6, and then 3 times 2 here is also 6. You can see we've also arrived at symmetric feature. So question number 2 or feature number 2 is symmetric. Alright. Okay, that's all. We have question number 3 or feature number 3. So let's confirm whether feature number 3 is symmetric or not. feature number 3, quadratic feature number 3 has its alpha squared plus beta squared, right, equal to beta squared plus alpha squared. Let's see. Let's see. For alpha, we have 2, right, and it's squared. For beta, we have 3 and it's squared. For beta again, 3 and it's squared, right? And for alpha, we have 2 also squared. So let's see, this is 4, this is 9, okay? This is 9 and this also 4. Let's see. 4 plus 9 is 13. Okay? And then 9 plus 4 at this point is also 13. Of course, we can see that feature number 3 is also symmetric. Okay, it's also symmetric. We continue that way until we are through with all of them. So this is obvious that this is symmetric. So let's look at feature number 4. Let's see if this space will be enough to do that. So we have 1, 2, and then 3 and 4, right? Feature number 4. Let's see if it is symmetric or not. We have alpha squared minus beta squared is equal to beta squared minus alpha squared. So let's see, without wasting time, that's feature number 4, right? Okay, alpha squared is 2 squared, and then beta squared is 3 squared minus beta squared is here, 3 squared again, alpha is 2 squared. Let's see what happens. Okay? We are at this point. This is 2 squared, okay? So let's see. 2 squared is 4. We have 4 minus 3 squared is 9 minus 9, okay? Is equal to, just watch this, very, very important at this point. This is 9 again, and this is minus 4. Let's see, 4 minus 9 is minus 5. Okay. You can see that, it's already showing. And then 9 minus 4 is 5. This is negative. This is positive. Negative, positive. What this means, minus 5 is not equal to plus 5. Therefore, at this point, we conclude that feature number 4 is asymmetric. Is what? Asymmetric. That means it's not symmetric. Asymmetric. Okay, solved. That one is asymmetric. It's not symmetric. Meaning, interchanging their values does not give the same answer or the same results. Interchanging their roots does not give the same results. Therefore, they are asymmetric. Feature number 4 is asymmetric. Let's confirm feature number 5. And we'll move on from there. This sounds interesting, isn't it? So let's look at feature number 5. Number 5. We have 3 alpha, okay, plus 2 beta, okay, all equal to 3 beta plus 2 alpha, okay? So that's what we have. Let's see how it goes. Let's see how it goes. I want to restate it once again. Feature number 5 at this point. For clarity purpose, we are at this point. 3 alpha plus 2 beta. Let's go. 3 alpha plus 2 beta. Okay? And the next one, 3 beta plus 2 alpha. And we have 3 beta plus 2 alpha. Okay, so look at it. What do? We substitute wisely. And this is 3 times 2 plus 2 times 3, okay? Then we have here 3 times 3 plus, okay, 2 times 2, so to say, if that makes sense. So let's see, we have 3 times 2 is 6, and then 2 times 3 is also 6. Good. So let's see. Take it once again. 3 times 2 is 6. 2 times 3 is also 6. Here, 3 times 3 is 9, plus 2 times 2 is 4. Okay? That makes sense. That makes sense, a lot of sense. Let's make sure that this is very clear for visibility, okay? Or readability. All right, so let's continue. 6 plus 6 is 12. Okay? Ooh. All right. Let's see. 6 plus 6 is 12. That is it. So 9 plus 4. 9 plus 4. Does it really make sense? 9 plus 4 is 13. What does this tell us? You can see 12 is not equal to 13. So this cancels this. The same thing here. It means that feature number 5 is asymmetric. It's not. It's asymmetric, not symmetric. So we've confirmed this. Okay? We have confirmed this. Alright? Feature number 5 is asymmetric. Is asymmetric. Asymmetric. Good. So let's confirm feature number 6 and see what we have there. Feature number 6, whether it's symmetric or not, we are going to confirm it now. And we have alpha cube. Okay, cube plus beta cube, right? That's this. We are talking about this. Is equal to, let's see what happens there. Is equal to beta cube plus alpha cube. I think that should be symmetric. If from the look of things, it looks symmetric. But let's not just assume. Let's put it into practice. Alpha cube is 2 raised to power 3. Beta cube is 3 raised to power 3. Is equal to beta cube again, 3 raised to power 3. And then alpha is 2 raised to power 3. So let's see. That's it. We're making progress. Very soon we're going to confirm whether it is symmetric or asymmetric. So, 2 cube, 2 raised to power 3 is going to be 8. It's giving 8. And then 3 raised to power 3. Of course, 3 raised to power 3 is 27. Because 3 raised to power 2 is 9 and then 27. This is 27. The same thing 27 at this point, and the same thing 8 at this point. So let's see. Let's see. Okay. 8 plus 27 is going to be 35 because 8 plus 7 is 15. Right? 5 carry 1. Put it here. That's 3. It's going to be 35. Let's see before we conclude. The same thing is happening there. Can you see? 27 plus 8 is also 35. Is also 35. Solved. It means that this is symmetric. It means that feature number 6 is symmetric. So we write there that feature number 6 is symmetric. Symmetric. Okay? Meaning, it means interchanging them, interchanging the roots either sides does not affect their results. The result remains the same. That's what it means. When you have two quantities and they are interchanged, and this interchange does not affect their results, they are said to be symmetric. But if it affects their results, even when they are multiplied by -1, it means they are asymmetric or not symmetric, so to say. All right. Thank you so much. Having watched up to this moment, I don't want to let you go without thanking you, okay? Subscribe, give me some thumbs up, put the bell button for constant notification, and do not forget to share with your friends, networks, and students. You know what? I'm signing out to prepare for the next lesson.